This is basically rod. Read the question. So here is introducing some small basic idea what already we have learned it that we have to apply it here. This is and these are the two strings. So initially the ring is at rest. So let the radius of the ring, let it be R. I think it's also having a charge, no? So let me give that charge. There's some ring, it will be connected to rod by some means by spokes that is not showing. It will be connected to that, it's not showing that one. So there's a string 1, there's a string 2. These are the overall things and the total charge on the ring, let it be Q. Initially it is at rest, not rotating. And what are the other things that are there? And the tension and the weight mg. So here the tension, let it be initial T naught and T naught. So T naught should be equal to 2 T naught minus mg equals 0 for equilibrium. Now I'm going to rotate it. After rotating, what is the maximum angular velocity which you can give it to the ring so that one of the string will not break up? We have a diagram like this. So next what I'm going to do, I'm going to introduce I'm going to rotate the ring but by some mechanism and the rod will remain horizontal. What will happen? And there's a uniform magnetic field is switched on. And it's telling that the tension in one of the string is, what is the maximum tension in strings they can withstand? 3 T naught by 2. And what is the maximum possible angular velocity? Why that angular velocity conditions are put? From where that condition for angular velocity should come? Now there's a rod and this is the ring. Why that condition for angular velocity? Yes, put it. So let's go for a rotating charge particle. Will it have any dipole moment? Go back to the yesterday's idea. Rotating charge particle, will it have any dipole moment? Yes, it will be there. The rotating ring also should be there. And the dipole momentum of the rotating ring and the magnetic field. So there will be dipole moment. Magnetic dipole moment will be set up. No, initially, though charge particle, though magnetic field is present, what is the state of the ring? What is the state of the ring? Ring is at rest. No? So no dipole moment will come. Though magnetic field is on. But the moment I start rotating, a torque due to dipole moment is produced or generated in the ring. Okay, how to calculate the dipole moment? So what is the expression for current? Q by T 2 pi by omega or Q omega by 2 pi. This is the expression for current and the dipole moment is given by m is equal to I into pi r square. What is I? I equal to Q omega 2 pi r square. So Q omega r square by 2. This is the expression for dipole moment. Dipole, magnetic dipole moment of rotating ring. So how it will be? It should be directed along omega naught. That's all, no? It should be directed along omega naught. So there will be a dipole moment as come into picture. That is what? This m bar. Now look at, there will be any torque, m bar cross b bar. So let's go for torque about the center of the ring. So what is the distance? The d is this is the distance what they're given for us. So there'll be torque, like the tension in the strings earlier were T naught, now they'll become T1 and T2. And why tension should change? So what is the tendency of this? The total system wants to rotate like this. About O, it wants to rotate. Already ring is rotating. So if I define the xy coordinate, and tell me like x is along the rod, x-axis is along the rod. Now you tell me about what axis the torque due to dipole moment is set up. This is m bar, this is m bar, b bar, m bar. Torque due to dipole moment should be like this, no? Curl fingers in the direction of arrow, open up the thumb will be along z axis. So the total system here, what will happen, will try to, the torque due to dipole moment will be like this. So it wants the entire rod and the ring to tilt. So shall I put like this, torque due to dipole moment? But what will happen? Because of the strings there, the tension in that will see that the tension will adjust itself and will see that the rod will remain straight. I think that's what somewhere he has mentioned here. Now it's switched on and the ring is rotated. Find the maximum omega with which the ring can be rotated if the strings can withstand maximum tension of 3 T naught by 2 and the rod will remain horizontal only. So we will balance torque due to dipole moment and the tension in the string to torque due to tension in the string T1. So what is the equation I should write here? No, torque about O should be equal to torque due to dipole moment. How it will be? It will be in this sense. Torque due to tension d by 2. Torque due to tension. This will be T1 d by 2. This this equation is the concept, the overall, the core idea of this problem. So why do this is due to rotating ring. Why tension should change? Because for equilibrium, and it's telling net torque will be 0. Now we can direction of torque due to T2. Oh, arrow. Yeah, fine. Okay, check once, all that one. Torque due to dipole moment, torque due to tension the string 2 will be anti-clockwise, torque due to tension the string 1 will be clockwise here. And the resultant torque should be 0 for the equilibrium. So therefore I'll write it now. This will be MB plus T2 d by 2 minus T1 d by 2. But we have, what is telling? If the strings can withstand a maximum tension of 3 T naught by 2. So one more equation I'll write it for vertical equilibrium. T1 minus T2. This is the initial. Okay, this one, yeah. T1 plus T2 minus mg equals 0. And which string tension should increase? T2 or T1?
T1.
T1 should increase, no? So therefore T1 I should assume 3 T naught by 2. And the T2 will be T naught by 2. What is the reason for that? the torque due to dipole moment, the angular velocity in what sense you give, that will determine which one should be taken 3t naught. Is it okay? The direction of angular velocity will decide which tension the string should be 3t naught by 2. So substitute value of m. So this should be, let's substitute all the values. So this should be equal to 0, equal to m is equal to q omega naught r square by 2 plus t2 is t naught by 2 d by 2 minus. Solving this, we'll get expression for omega. You look at this one, torque due to tension. What is the axis? Axis is about z axis. All these torques are set up about z axis. The z axis will be like this, passing through O. So this, I think please do look at different things here. Look at this one. The O is the center of the ring. So above z axis, there will be torque due to dipole moment will be set up. It will try to rotate the ring about z axis. Okay, clear this one now. So definitely what will happen? Here the tension the strings will get altered. So torque due to dipole moment and torque due to tension the string 2 should be balanced by torque due to tension the string 1. So definitely here tension T2 will decrease, this will increase. So therefore I should assume T1 as 3T naught by 2. Is it okay now? I think the answer will change. You can't just assume randomly T1, T2 values. One of the where tension will increase, tension here will increase, here will decrease. I'll write it nearby. Tension here increases. If you make angular velocity 0, you stop the ring. Again, what happens? The tensions, they'll adjust themselves to T naught, and they'll balance weight. See, the weight will be acting vertically. This is for translational equilibrium. Along y-axis, equilibrium along y-axis. Okay, fine. So some very good application problems are there, especially dipole moment no torque will come. So you do get good varieties of problems. Try to analyze. The only idea is what torque due to dipole moment, m bar cross b bar. Oh, the application problems are very important. You have to make observations.